we're going to talk over and under estimates and how to determine that. Okay? Wrong. Okay, I really need your help. If I'm writing too quickly, slow me down because it needs to be legible. Okay, for Oriana. So please keep me accountable there. I do get in a hurry. It's just that's not.
Yeah, how does that work for you in college? Is that curiosity?
Over and under. That's not what I want.
That says
okay,
over and under.
Don't. I'm trying to think of too many things at once. Over and under estimates. In college, I wasn't in such a hurry all the time. No, I didn't have as much responsibilities as you know. Where'd you go? Nice. I played football and I did school. That's it. Like that was my job.
So you taught in college?
No, this is while I was speaking educated.
Now you have.
Now I'm like, oh, what do I have?
Family.
Well, I teach full time. I have kids and I have a wife and I have a ranch. And I drive 2 hours to get
What?
So I like, I gotta get something done. Okay. We need to talk about left and right Riemann sums, midpoint, and trapezoidal sums, and how to determine if those are under and over estimates. Okay. So I'm going to ask you a series of questions, and I think you're going to actually figure this out on your own, right? So let's consider the one function that's our favorite, right?
Well, yeah.
From 0 to 2, right? Remember this notation? Left Riemann sum with 2 subintervals. Okay, so draw that up. The left Riemann sum, correct? Yeah. So you start on the left, the height is 0. Draw a rectangle. Then the height is 1. Draw a rectangle. Is that an over or under estimate? Okay, it's an underestimate. Okay. You okay with that?
Yep.
All right. How about R2? Will that be an over and underestimate? It will be an overestimate. Correct?
Correct.
Okay. Let's consider the same function but on a different interval.
So L2 over this.
Right. So yeah, you're catching on here. L2 will be an overestimate here because
It has to go over the graph.
right? Okay, and then R2 would be an under estimate. Correct?
Correct.
Can you tell me what conditions will create an over or under estimate for left and right endpoint approximation? Okay. What do you mean positive and negative? Okay. When you say positive and negative function, what we interpret is positive is above x-axis, negative below. So what words are you describing? You need to edit there.
Left and right of the y-axis.
What if I do this?
Ruin our whole plan.
That ruined your plan.
Is this all we use for this?
That is still.
It's the complicated stuff that's coming down, and then it's like by accident. It's like, if it's,
Okay, does that ruin your conditions that you just gave me?
Yep.
Yeah, that's, okay. So what is their common thread? What do we know about functions? What have we studied? Okay, we've already eliminated positive and negative. Okay. Well, what did you say? Slope. Okay, could that determine
Yes.
the factors here? We'll get into what you
if
said.
it's like, if it's concave down or concave up, and you know which side of the y-axis.
Concave up, right? L2 is under. Concave up, L2 is over. Does that reasoning work?
Yeah, but you have the two sides of the y-axis.
It's a lot easier than that. Okay, what's the last thing we haven't talked about? Slope. This function is a positive slope. What do we call that mathematically? Increasing. And this would be decreasing. This would be. Can somebody give me a common thread? If the function is increasing, is this true? Okay. If this function is decreasing, L2 is n, and decreasing, overestimate. Okay. R2 is an overestimate if we are increasing, underestimate if we are decreasing. Okay. So left and right endpoints deal with increasing and decreasing functions. Okay, so let's write that up. So for an increasing function, don't forget the fun and function.
So when you do the, left and right, triangles, is it gonna be the same distance away? Like, is it gonna be the same overestimate as it is underestimate, so like, you can find the actual area of the curve?
Excellent question. No.
No.
No, we cannot say that these two would average to be the areas. Is that what you're kind of getting at? No, we can't do that. I would like it for it to be that way. I really would, but okay. So if we have an increasing function, the left-handed Riemann sum is an underestimate. Correct? That's what we concluded. And the right Riemann sum, use shorthand here, makes things easier, is an overestimate.
Yes.
And if we have a decreasing function, it switches, correct? mathematicians look shorthand to try to keep up. Okay. Aurora, how do I show a function is increasing or decreasing? Derivative is negative. What does that mean? That it's the function is decreasing, derivative is positive, function is increasing. Do you want me to write that out? Like we've done it before many times. Do you want me to write it out? Thank you, Kate. Anybody else?
Yes, thank you.
Yeah.
So, right, calculate derivative. Yeah. Equals what? Critical point. How do we calculate critical points? So it equals 0. So x is 0. What's our next step? First, see if it's increasing or decreasing. Sign change analysis. So we need f prime at -1, f prime at 1. Decreasing? Increasing. Maximum or minimum? Minimum. Yeah, because it goes from negative to positive. This is a minimum. So there's a little review. Okay.
So we could say the function is for all x smaller 0 under 0, and decreasing is for all x plus 0.
That's perfect. Okay. Good? Maybe split that group up. Oh, exactly.
The one thing I did.
Okay, let's talk about midpoint and trapezoidal sums.
Shut up.
Same function, right? Make it easy. Over or underestimate?
Blind estimate. Closest estimate. Neither. It depends on the scope.
How do you know that?
Yeah.
Because it's more under than more over.
How do you know that?
Because if you look at the rectangle, there's more rectangle below the line than
You
above
got
the line.
like you can't just say because and
Yes, you
restate
can.
your conclusion. That's faulty logic. Come on.
Because look at the picture.
Because look at my not to scale picture.
Wouldn't it be
Please.
because you have two triangles on the rectangle and the two back.
The question is, which is bigger area? Here or here?
You can find that? I bet you.
David has a very good point. This slope is increasing, correct? It's getting steeper. Well, I can't hear you with everybody else all up in arms. So, okay. Oh, brilliant one. Educate us.
No, I don't
Oh, now you don't want to. I haven't taken anything.
Go for it.
If that kills your motivation, you need to toughen up. The slope is increasing, correct?
Yes.
So this triangle will be bigger or smaller?
Bigger.
Bigger? Or bigger?
Yes.
Right. The right one's bigger. The right one would be bigger.
Okay, I'm gonna let you simmer on that. Let's talk about the trapezoidal sum.
Yeah, what do you do?
Let's simmer on that.
Arthur, I think you're haters.
I'm a math teacher, dude.
Point through it.
That's just an estimate.
All I have to do is exist and people hate me. Okay, trapezoidal sum is an.
Over.
Okay, I will accept that answer as is.
Shut up. We don't need that in our life. We don't need the defense.
It doesn't have any contact, and it's just a straight line, it's gonna be exact. And if it's concave up,
This is why people watch this, dude.
Subscribe and like to our videos.
Are you confident in that?
Bell for notifications every time we get a video.
so when you ask, and then
We'll make more videos on this next one.
You said concave up is an overestimate? And concave down is an underestimate. Canyon is a confident young man at this point. So if I do a concave down function, we're going to check his assertion here. Trapezoids. Underestimate.
Yeah.
Correct, because everything's under it. Look at the picture.
Look at the picture.
Look at the picture.
Underestimate for trapezoidal,
Is that a
right?
good answer for like EP? What is it, under or over? It's under. Just look at the picture.
what if the graph never runs above?
Okay, now midpoint. Anybody?
It is. It,
It's an underestimate.
it's an underestimate because the triangles on the outside are smaller than the triangles on the inside.
He's just gonna read.
Well, this is one of the things he's confident we'll figure out on our own. He's asking questions, probably now.
Well, I mean, there's only two choices, guys. It's either under or over.
Yeah, but we have to figure out why. Yeah, we have to figure out.
This is almost like quarter comp side. These are the opposite.
What's the opposite?
And there, if we keep pressing go, it's not gonna fix itself with you. If you keep asking us questions, we'll fix ourselves.
Oh, so you can spam me and it works.
As long as we're not confused.
I feel like if it is, just a function for a place.
Okay, how do you feel that? Like I can just feel
I
it.
think
Okay, that's a more appropriate word. Now back your thinking up with reasoning.
Psychology.
the area that is not under the function is
I think when the function is
Tough enough.
I think when the
Tough
function
enough.
is increasing or positive, I think that.
Okay, concavity, trapezoidal is very obvious, right? Okay. Midpoint. not so obvious.
So is it underestimated? Over. Is it increasing or?
You're not trying to say random word.
Yeah.
Just trying to say a word till you say
Okay.
yes.
It's over for that.
Under, and it says,
Do
darn
you,
it, why?
do you agree?
Yes.
No.
Yes.
Why?
Yes, it makes sense.
It doesn't. Tell me why.
Because it's opposite of the trunk.
Is this triangle larger than this triangle?
Yeah.
Yeah, it is, because it's concave up. The line is sloping upwards. It creates a larger triangle here than here. So this is an underestimate, it's an overestimate. This is a very rarely addressed item, okay? Most of the time you're going to have to do this analysis with left, right, or trapezoidal sums. Right, so in summary, trapezoidal sums, over and underestimates are dealing with concavity, right?
No.
Left and right Riemann sums deal with increasing and decreasing. Okay? That's all you need to worry about. Elizabeth, do you have any questions?
Can you go back to the other?
So the area this section.
Toughen up.
Can
Regroup
Okay.
yourself.
Now do it.
you go back to the other side?
Yeah, sorry.
The under one?
Yeah, the one where it's like under the square thing, and then the other square thing, this triangle is bigger than this triangle.
Is this on the bottom?
Like that.
You have 2 free responses.
This gets closer to the edge of this square. So the width gets a little smaller.
No, that's
Like
it.
a height.
Again, 15 minutes each is your time limit on the AP exam, so kind of keep that in mind. But at this point, we're still working towards getting better at these, so
Still struggling
We'll
on
check
that.
it tomorrow.
Oh, that's an over.
what is?
How M2 is an over.
Because my drawing sucks.
Okay.
The midpoint is right here.
Oh,
Right.
that makes a bit more sense then. Oh.
My drawing sucks.
Yeah, okay. I'm good now.
I'm not an artist, except when I can use power tools. I'm a woodworking artist, not a drawing artist. Thank you. Okay. You have 10 minutes-ish. Let me know if you have any questions on those 3 responses. I would scan through them. If you have any immediate questions, you'll ask those.
Did the binder stuff the thing of those two
Delete
things?
stuff.